calculate the heat energy required to convert 2 kilograms of ice at minus 12 degrees Celsius to steam at 100 degrees Celsius. So I told you that anytime you're given something like this, okay, it's advisable that you first sketch the temperature time graph. Okay, where you have temperature over here. Please, I hope you are following.
Yes, sir.
And time. Then we had the minus 12, which is, so if you put 0 here, minus 12 will be somewhere below. It's not drawn, we are not drawing it to scale. Okay. So if let's say minus 12 is there, let's put 100 degrees somewhere here. So from what most of you had, the temperature started from minus 12 and it increased till 0. Then at 0, the solid changed to liquid. Okay. And then from there, it increased to 100 degrees. So this supposed to be the same level. Okay. It increased to 100 degrees. Then after it got to 100 degrees, what happened is that it changed to steam. So if you leave it at this stage of the graph, okay, then it means that you've not converted it into steam. Okay, it means you are leaving it at 100 degrees in the liquid state. So it means that it has to what? Change to steam. Okay, we are not told that the temperature of the steam increased. If it increased, it would have continued, but there was no increase in temperature of the steam. So you can see that these are the stages in there. We have 4 stages. Okay, so we have sensible heat at the stage Q1, latent heat Q2, sensible heat Q3, and then latent heat Q4. So these are the 4 stages. Over here, we know that it's supposed to be M, C, change in T. The Q1 is sensible heat. Q2 is latent heat. Okay, but latent heat of fusion. So M, L, subscript F. Then sensible heat again, M, C, change in T. Then, and the Q4 is latent. So M, L, V. Okay, so latent heat of vaporization. Okay. Down here, the specific heat capacity is that of ice because it's in the solid state. Okay. And over here, the specific heat capacity is that of water in the liquid state. So let me put a subscript W there. So knowing this, we can quickly just do the math. So Q1 will be equal to, the mass is 2 kilogram times the specific heat capacity of ice, which is what? 2100 times the change in temperature from, it moved from minus 12 to 0. So the change in temperature will be this, right? 0 minus minus 12. Okay, which will give us a change in temperature of 12. And that gives us a total of 50,400. Please, are you following? Joules. So that's the energy required to move it from minus 12 degrees Celsius to 0 degrees Celsius. Then, what about the latent heat of fusion, which changes it from solid to liquid at this stage of the graph? Okay, so that will be Q2. And Q2, we are told is what? M, L, F. So what is our M? Is still 2 kilogram times, what is our specific latent heat of fusion? That is over there. So that's
300.
3, good, 336,000.
36,000.
Very good. Please, I hope you are all following. Those who
Yes,
didn't do
sir.
the homework. You see that those who didn't do the homework, they are quiet. All right, so what's the answer?
672,000.
Very good. So those who did the homework, you see that they are talking. All right, so let's deal with the Q3. Q3 is sensible heat. Okay, and that is increasing the temperature of liquid from 0 to 100. So that would be the mass M times the specific heat capacity. But this time it's not in the solid state, so we don't deal with the specific heat capacity of ice. We deal with the specific heat capacity of water in the liquid state. Okay, so that's 4,200 times the change in temperature. Okay, that's 100 minus 0. Okay, so the change in temperature is 100. So what's the answer? Nanaya and Mary, one of you should answer since you didn't do the homework. Nanaya, Mary. And don't log out because I know you're online. And I know you can hear me. Mary, what's your answer? Mary, unmute your microphone and punch it in your calculator.
Sir, please, 840,000.
840,000. 840,000 what?
Joules.
Joules. Okay, so keep in mind that this is energy. Then we have the Q. So that's Q3. Then the last one is Q4. Q4, which is latent heat of vaporization, which is given as MLV. So the mass is 2 kilogram times the latent heat of vaporization. That is what we have over here, which is 2,260,000. So what's the final answer for Q4?
$4,520,000.
Good. Robert, I didn't want you to answer, but you've answered it. I wanted those who didn't do their homework to answer. Okay. All right. So from here, what do we do? Christian, welcome. I didn't receive your homework. Christian, you're welcome. I can see you just joined the class. Okay, he's quiet. All right. So what do you do from here? Nanaya, what do we do from here? So we've been able to calculate the energy at each stage of the graph. Yes. So what do we do from here?
You add all of them.
You add all of them to get a total. All right. So the Q total. So add it for us. Yes. So what do you get after you added them?
You get 6 million. You get 6082400.
Okay. 6,082,400 watts. What's the final? What's the unit? What's the unit? Yes. What's the unit? Yes. Anaya, we are not done. What's the unit?
Joules.
Joules. Very good. Okay. So that is for your first question. Okay, so that's the heat energy required to move it through all the stages like that, all the way to this point. Then the second homework,